Okay, so f of x equals 1 over x. Thus, f of x minus 1 equals what? I'm sorry? Yeah, because what do you do? If it's x, okay, but you've replaced x by x minus 1, so we're going to write that as 1 over x minus 1. So that's a function 1 over x minus 1. Now, what would you do to construct the graph of y equals f of x minus 1 based on the graph of y equals f of x? Well, it might help you. I didn't say construct the graph of the f of x function, but we can easily make the table for this, assuming you get the arithmetic right. You get negative 1/2, negative 1, negative 2. Division by 0 is undefined. 1/2 gives you 2, 2 gives you 1, 1 gives you 1, and 2 gives you 1/2. And you get your graph. And of course, this is something that was assigned. Now let me get straight over here and see if I can balance the left and the right a little better than people. So there's negative 2, there's 2. Here's negative 1, here's 1. Here's negative 1/2, here's 1/2. Those intervals aren't exactly equal. I still mess it up. When I look at it here, I make this one too short. When I look at it from over here, I make it too long. I'm distorting the graph. And we do distort graphs, but we don't distort scales. We're not distorting the scale. Okay, so here we're going to have 2, 1, and of course there's 1/2. And here's negative 1. Here's negative 2. Here's our negative 1/2. So our points are going to be here, 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 and here, right where I labeled the negative 2. I put an X there, a negative 1, and kind of messed that one up too. Okay? And anyhow, there's the curve, and we know it becomes asymptotic here. Kind of what we talked about the other day. We know it's going to be asymptotic here. So there's a rough picture of the curve, right? Of the graph of the extended basic function. And I should say extended because I do want to distinguish extended, complete, and basic. Okay? Then, what did we see over here? If we want f of x minus 1, if we replace x by x minus 1, that should shift every point 1 unit to the right. Okay? So, the graph of f of x minus 1 1 unit to the right We don't know that, but we suspect that from what happened with the x squared graph. And if we went through the table and everything is rescaling, we would discover that, yeah, it works for any graph. So what we said about the x squared graph, if you replace x by x minus 1, you shift the graph 1 unit to the right. Shift every point 1 unit to the right. Same thing happens with this. So for example, the point 1/2, 2 shifts 1 unit to the right. The point 1, 1 shifts 1 unit to the right. The point 2, 1/2 shifts 1 unit to the right. And here's the new graph in the first quadrant. Okay? Now, every point here shifts 1 unit to the right, which means this one shifts over here, this one shifts to here, and this one shifts to here. So now we have these points. And also, the y-axis is an asymptote. This approaches, well, this graph approaches the y-axis as an asymptote. This approaches the y-axis as an asymptote. Your asymptote also shifts 1 unit to the right. Well, let's get through the right point here. Okay? So the asymptote of the y-axis shifts 1 unit to the right. So the y-axis, every point of the y-axis shifts over here. And there's a picture of how you can get the graph of 1 over 1 minus, over x minus 1. Okay? From the graph of 1 over x. Now there are other transformations that we can do. This is the first one I ended up showing you. I was debating between the vertical stretch and the horizontal shift. Okay? It turns out if we replace the numbers on the y-axis, instead of going from 0 to 2, we go from 0 to 4. Okay? Then that gives us the graph of B2 f of x. Okay? If you want to raise or lower the graph, you add or subtract a number to f of x. And I'll give you a little bit of preliminary to that in the assignment so we can move right into it so you understand these transformations. And also a little bit of function notation. Okay?